learning, but we are not used to with the deep learning method, and we use machine learning to model this problem. So the first thing is, where do we get data sets relating to anti-cancer peptides? And we do have lots of data sets relating to cancers, peptides like cancer PBD, and difference in peptide databases, UniProt. And we need to validate those peptides, whether those validated peptides do have activity relating to anti-cancer peptides or not. And as we can see that all these peptides datasets are time series datasets, and they are the combination of 20 amino acids composition, and their composition doesn't determine their activity, what they do. So we need to model these problems by using some kinds of features for predictions. So our main target is to develop a competition model, train and test to evaluate on the independent data sets whether developed model, proposed methods achieve expected prediction accuracy or not. So we do some kinds of statistical analysis on two kinds of data sets, like SCP-740 and SCP-240 data sets, like SCP-740 as the main data set and SCP-240 as the independent data set. So we see that most of the peptides fall within the range of 40, 50, and 60. So we take the chunk of 40, 50, and 60 for the prediction analysis. So first thing what we do is we post the data that they may consist of variable length peptides, and we fix those peptides into some kinds of 40 or 50 chunks peptides and featureize those peptides using some computational method, as well as we do have a servers for that also. But we represent that in terms of numerical vectors. For those, we selected binary profile features which represents the sequence information or sequence order information. Amino acid compositions means represents the number of residue that is more prevalent in the sequence, and amino acid index that represents the biophysical activities relating to anti-cancer peptides. And some kind of novelty that we do in our work is data argumentation that are not introduced in peptide-based argumentations. But it's so common in image argumentations. And next one is model building. Like we try to several linear, non-linear model, ensembles model, stacking models, but we achieve the expected results with using method adaptive boosting methods. So for this modeling, we use ADA boosting classifier. It uses some kinds of technical as boosting classifier, and you need to determine the best classifiers for these. And we try several linears as well as non-linears. But using a non-linear models, especially the random forest model, which works like an if-else loop, it is giving a better accuracy. And we encode those peptides in terms of profile features, amino acid index, and acid compositions, and use the base learner for the prediction. And we are very proud that we get a better results with using these nonlinear models as a base learner for predictions. And we optimize the models, we didn't optimize the ADA boosting classifier, but we optimize the base learners, so it can correct the errors that is present within the base learners. So this is the result that we achieve, we do some feature analysis, which of the features is more prevalent or have a strong momentum for the predictions. And we find that the combination of binary profile feature, I'm sorry, like the feature is not here, so the combination of binary profile feature and acid index and acid composition gives us a better result for the predictions. And we calculate this in terms of MCC. And we perform some analysis on the two data sets, and we are able we achieve the better performance using ADA boosting classifiers, which is about 90% accuracy for these data sets, SCP-740 and SCP-240. This is the result that we get from our modeling. Like we get maximum accuracy of 86% for the SCP-740, and with SCP-240, like we apply data argumentation technique for SCP-740 and SCP-240, and it was doing better for the samples with the least number of proportions, representing positive and negative samples. And we compared our results with the state of methods, and we are getting a better accuracy than the previous state of methods. So we are proud with this. So for the validation, like if you are interested to work on the peptide relating to different neurological disorders, there are lots of research regarding the peptides because of the limitations of the drug molecules. Like our body, if our body is prone, exposed to the drugs, then our body can develop a resistance for that. But the peptides, what the good things is with the peptides is it doesn't have side effects. It doesn't have side effects as well as prolonged exposure to the peptides doesn't develop a resistance for any kinds of diseases. And we do have a validation server, like it's one example for this. If you are working with anti-cancer peptides or any antimicrobial peptides, then you can visit these types of server for validation of your data sets, as well as feature validation. They do have some extra information relating to multi-distance, which of the peptide sequence is more prevalent in what kinds of peptides. So this can be templates for you. So this is the summary of our work, like what we do, like represent the peptides or time series data sets in terms of physicochemical properties, composition, as well as binary profile features. And we have done some feature analysis to find which features is more strong for the prediction, and we find that the physicochemical properties have more tendency for predictions, like it can pass the physicochemical or bonding informations that resides within the peptides. And we argument that cell samples, but we didn't add argumentations to the features that represent the sequence order information, but the features that represent the physicochemical properties. And we achieved, the last one is we achieved the maximum accuracy and MCC of 83% and 81.65%, which is the success of our work. And what this method concludes is that we can apply some kinds of noise injection methods to our peptides data sets, not only to the image data sets also. So it can be a direction for someone who are working in time series data sets. So this is our results.